Okay, we're going to switch gears a little bit. Again, remember, we're sort of pulling out some of the highlights of this unit. So these are two things that probably wouldn't have happened on the same day had we been in school, but by getting rid of other pieces, time-wise, we're putting them together today. So we're going to talk about what's a tangent. So a tangent is a line intersecting the circle in exactly one point. That point is known as the point of tangency. You're probably thinking, how can you only hit a circle once? Well, the truth is, it barely grazes the surface. You want to think of this circle being this round object of still having a whole bunch of points that are making up that round circle. And so every one of these little points going around this circle is just a little bit off from the one that it's next to. Hence, they don't ever make a straight line. It's what makes a circle round. And so I can have a line that just sort of scoots right past a circle and it just hits that one point on that very edge. That is the point of tangency. So line AB would be considered tangent to a circle. We're saying circle P, and at point C. So it's telling you where it's tangent to that circle, meaning what's the point that they both share. When we have tangents, oftentimes we can use what's called the perpendicular tangent theorem. Well, we know perpendicular, right? Perpendicular says, hey, I make right angles. So what this is saying is we're going to get some right angles when we have this tangent line. If a line is tangent to a circle, then it is perpendicular to the radius at that point of tangency. So wherever you have a tangent line, if you go from the center of your circle to that tangent point, that's going to be a radius, and that will always form right angles. So one of the ways that this can come in handy is we might actually have a tangent and a radius, and if we draw in that third side, guess what? Now we've got right triangles, right? There we go. So this is actually asking you to determine if ED is tangent to the circle. So what that means is determine, do we have a right angle? If we do, great, it's tangent. If we don't, then it's not tangent. So think about what we use when we have right triangles. We can use the Pythagorean theorem. I can say, okay, does this mean that 3 squared plus 4 squared is equal to 5 squared? Okay. And you're just checking to see if this works. Notice I don't have a letter that I'm solving for. I'm just sort of checking it. So this is 9, right? This is going to be 16. And 5 squared is going to be 25. And so if I add this, this is also 25. We're equal to 25. And so that means, yeah, this works. And so if I wanted to give a final answer, I would say this is tangent. And so if I repeat that process over on the other example, I would have something like 4 squared plus 8 squared equal to 9 squared. Okay. Remember that your hypotenuse must always be that C value, right? Remember the tangent and the radius is where that right angle is supposed to be. So this is 16. Here we're looking at 64. And then we're looking at 81. 16 and 64 added together gives me 80. So is 80 the same as 81? Nope, it's close, but no cigar. So this would simply mean that this is not tangent. Okay, in terms of why this is working, okay, basically if your Pythagorean theorem works, then it has to be a right triangle, so it's tangent. So when my Pythagorean theorem does not work, like on the question on the right, that's because this is not actually a right angle, and therefore it doesn't hold true. When the Pythagorean theorem fails, it's because you're trying to use it on a non-right triangle. The other thing that happens with tangents is what I like to call the ice cream cone theorem. Trust me when I say this is not a technical mathematical term, but it becomes the super easy way to remember it. Think about an ice cream cone in your head, right? If I'm trying to put a scoop of ice cream on top of that ice cream cone, it's going to do me a lot of good if those two sides match so that my ice cream doesn't fall onto the floor, right? So the ice cream cone theorem simply says if two segments from the same exterior point are tangent to a circle, then they are congruent. So here's my picture. I have these two segments. They start at an exterior point. They are tangent to my circle, and basically the length of A is going to be the same as the length of B. Think about flipping this sort of up on that point, right? There's your ice cream cone. The two sides of my ice cream cone need to be the same. So if we look at an example, here is my example. I've got these two segments. If those are tangent, then that means that 2x plus 37 has to equal 6x plus 5, right? And so we want to solve for x. We're going to subtract our 2x from both sides. That's going to be that our 37 is equal to now 4x plus 5. We can subtract our 5 from both sides. That gives me 32 equals 4x. And when you divide both sides by 4, 8 is going to equal x. Okay, real simple. Looks like an ice cream cone. Two sides are the same. Set them equal. Solve for x. The other way this can work is they can actually sort of put the circle inside a shape. And so what's going to happen then is what you have is like one ice cream with 4 cones stuck to it, right? Each one of these corners is technically an ice cream cone because all of these have this one tangent point that they have. So I'm kind of marking those points roughly, right? So you do still have a bunch of ice cream cones. So it says find x, find y, find AB. Well, here's x, this side's 2, so guess what? X has to be the same, right? Ice cream cones, they got to be equal. So then let's find y. Well, the 5y plus 7, right, has to equal the 3y plus 19. Solve for y. So I'm going to minus my 3y from both sides. That makes 2y. Oops, plus 7 equal to 19. We're going to minus our 7. 2y is going to equal 12. Divide by 2, y will equal 6. And so lastly, they wanted me to find the length of AB. AB is over here. That means I simply need y minus x. So let's do it this way. Oops. AB is equal to y minus x. So 6 minus 2 makes AB have a length of 4. The other thing that can happen a lot on pictures like this is if they give you information on all of the corners, they could ask you for a perimeter, meaning go around the shape, add up all of those pieces, and get a full perimeter going around. So that's a possibility on pictures like this too.